Okay, so you know how to add fractions, but the ancient Egyptians used fractions differently than we do today. You see the difference? They used only unit fractions, fractions where the numerator was always a 1. This could be helpful if, say, you wanted to divide 5 loaves of bread between 8 people. Instead of making many strange cuts, this equation suggests to give each person 1/2 a loaf and 1/8 of a loaf. Multiplying this equation by 8 confirms that 4 loaves are divided in half and 1 loaf is divided into 8 pieces. Of course, we could write a fraction like 12/17 like this, but the Egyptians also wanted the denominators to be distinct. So for example, we could write this. Any fraction can be written as an Egyptian fraction. A crude way to do this is to use this formula, which splits a unit fraction into 2 other unit fractions. For example, since 2/7 equals 1/7 plus 1/7, we can simply apply the splitting formula to the second term to produce this formula. Similarly, the splitting formula can be used multiple times on the fraction 3/7. Although this approach works for any fraction, it may produce a ridiculous number of terms. Another approach to getting an Egyptian fraction is to use the greedy algorithm due to Fibonacci. The idea is to first subtract the largest possible unit fraction. For example, the largest unit fraction, which is less than 4/625, is 1/157. How did we get 157? Calculate 625 over 4 and round up to get 157. Now take the remaining fraction, subtract its largest possible unit fraction, and so on. Note that in each step the numerator of the remaining term goes down. This always happens with the greedy algorithm, and so the fraction m/n can always be written as an Egyptian fraction with no more than m terms. However, the greedy algorithm can produce denominators that are big enough to scare a mummy and a mummified cat. So, for any integer n, the fraction 4/n can be written as an Egyptian fraction with at most 4 terms. Here's the mystery question. Is it always possible to write 4/n as an Egyptian fraction with only 3 terms? For example, we saw 4/625 earlier, but there are many ways to write it with only 3 fractions. This problem, posed by Paul Erdős and Ernst Strauss in 1948, is now called the Erdős-Strauss conjecture, and it's still unproven. In the previous example, a choice with smaller denominators is this formula. This was found by using the simpler formula and dividing each term by 125. This example highlights that to prove the Erdős-Strauss conjecture, it is sufficient to consider only the fractions 4/n, where n is a prime number. In an effort to show that a large swath of numbers fulfill the Erdős-Strauss conjecture, some special formulas, like this one, help. If n equals 5, 8, 11, 14, 17, so on, numbers which when divided by 3 have a remainder of 2, this formula produces an Egyptian fraction with 3 terms. Related to Egyptian fractions are fascinating formulas, such as if there are n resistors in parallel, then the total resistance R satisfies this equation with unit fractions. Now you can muse over this cool Egyptian pie chart, or you could answer the following question. How many ways can you write 4/11 as an Egyptian fraction with 3 terms?